This video presents the solution to activity number 2. The first topic is about work problems. So, in solving work problem, we have to recall the rate of a worker, and that is equal to 1 over T, where T is the total time for a worker to finish the work. We have also the part of work done by a worker, and that is equal to the rate of the worker times the time he spent working. And for our equations, we can use the first, which is if we have many workers working on the job, then our equation can be written, or we can make an equation involving the part of work done by the workers, and that is summation of the part of work done is equal to the total work done. Now, for the right side of the equation, the total work done is equal to 1 if one whole work has been accomplished by the workers. Then the third equation, we can write the summation of the individual rates of the workers is equal to the combined rate. Okay? So to illustrate, we have problem number 1. A pipe used to fill a tank can fill the tank alone in 8 hours. A drain pipe can empty the tank in 12 hours. If the tank is being filled for 6 hours while the drain pipe is accidentally left open, how long would it take to fill the tank if after 6 hours the drain pipe is closed? Okay, so we can tabulate our rate and the time that the pipe and the drain work. No? So let x equal to the time for the pipe to fill the tank after the drain is closed. So the pipe fills the tank for 6 hours, and then after 6 hours the drain is being closed, and then the pipe continue to fill the tank. So the remaining time for the pipe to fill the tank without the drain is the value, or is the x represented here. So we have now, so for the pipe, the rate is 1 over 8 because the pipe can fill the tank in 8 hours. So 1 over the time to do the job. So that is 1 over 8. Then the drain can empty the tank in 12 hours. So the rate of the drain is 1 over 12 because the drain can empty the tank in 12 hours. Then for the time that they work, so the drain pipe work only for 6 hours. So at the start, up to 6 hours that the pipe or that the drain is closed. Then for the time of the pipe to fill the tank, so that is 6 plus x. 6 hours together with the drain open, and the remaining x, the time for the pipe to fill the tank without the drain. So if you multiply the rate and the time, so we have the part of work done by the pipe, and the drain, we have also the part of work done by the drain. Now take note that if the pipe does positive work, the drain does negative work. So meaning, when we add the part of work done, this is negative for the drain. Because the pipe fill the tank while the drain empty the tank. Okay, so we can now use our equation, that is, if you sum up the part of work done, that is equal to 1 because 1 tank is being filled up. So we have that here. So 6 plus x over 8 minus 6 over 12 is equal to 1. And from this, we can solve for x. So x is equal to 6 hours. So the total time for the pipe to fill the tank is equal to 12. So 6 hours together with the drain plus 6 hours when the pipe is alone filling the tank while the drain is closed. Problem number 14 we have here. Working together, Manny and Kelly can design a website in 6 hours. Working alone, however, Manny would design the website in 2 hours less time than Kelly. How long would it take Kaylee alone to design the website? Okay? So, we represent, let X equal to the time of Kelly to design the website. So, the rate of Kelly is 1 over X. Then, the time for Manny to design the website is X minus 2. Because Manny can design the website in 2 hours less time than Kelly. So, take note that the rate of work for Manny is 1 over X minus 2. No? So again, if we recall, rate is 1 over the time to do the job. So for Kelly, the rate is 1 over X. For Manny, the rate is 1 over X minus 2. Now, take note that when they work together from start to finish, they can design the website in 6 hours. So meaning, if they work combined, so they can finish the work in 6 hours. So, the combined rate there is the reciprocal or 1 over the time for them to finish the work together, and that is equal to 1 over 6. So, we can use our equation number 3. So, we have the summation of the individual rates equal to the combined rate. So, that is 1 over x plus 1 over x minus 2 is equal to 1 over 6. And x is equal to 13.1. Next problem, we have number 20. A swimming pool has 2 pipes A and B used for filling with B bigger than A. The small pipe A working alone can fill a pool in 90 minutes. At a certain day, when the pool is empty, this pipe A is put into operation to fill the pool. After 60 minutes of operation, the bigger pipe B is opened and the 2 pipes fill the pool completely in 10 minutes more. How long would it take for the bigger pipe alone to fill the pool? Okay, so we will start with the representation. So let x equal to the time in minutes for the bigger pipe B to fill the pool alone. So we can have the table. So for the smaller pipe, it can fill the pool alone in 90 minutes. So the rate of that A is 1 over 90. Then we do not know how long B can fill the pool alone. So we represent the time by x. So the rate of B is 1 over x. Then the time in working. So pipe A worked for 70 minutes. So that is 60 minutes filling alone. And then another 10 minutes together with pipe B. So the total time for A filling the pool is 70 minutes. While B has filled the pool only in 10 minutes. Then for the part of work done, we can multiply 70 times 1 over 90, then 1 over x times 10. Then we can sum up the part of work done. So if we sum up the part of work done, that is equal to 1. One swimming pool has been filled up. So that is 70 over 90 plus 1 over x times 10 is equal to 1. And then we can solve for x, that is equal to 45 minutes. Another variation for work problems is when we have the unit of work in man-hours or in man-days. So to solve problems involving this type of problem, we simply have the equation, the man-hour per work in the first situation is equal to the man-hour per work in the second situation. Now, this equation is simply proportion, considering that the workers have the same rate, and that rate is expressed in terms of man-hours. So to illustrate, we have number 2 problem. 30 men can do a job in 80 days. 20 men started the job. After 30 days, 10 men were added. On the 56th day, 20 new additional workers were hired. In how many days was the project has finished? Okay? So, the total man-hour here is equal to 30 times 80. Huh? So, this job can be done by 30 men working for 80 days. But the job has not been accomplished by the 30 in 80 days, the 30 men working in 80 days. Because as you notice, at the start, there are only 20 men working. Then we have the additional of 10 men after 30 days. Then another additional of 20 days or 20 men on the 56th day. Huh? So to answer the problem, we will simply equate the total man days to accomplish the work as to the total man days on how the job has been accomplished. So we have this equation now. So the 30 times 80 is the total man days for this job. And this is done by first 20 men working for 30 days. Then after 30 days, 10 men were added. So we have now 30 days or 30 men working. And then this is up to the 55th day. Huh? So meaning from the 31st day to the 56th day or to the 55th day, there are 25 days. Now, so we have 31, 32 up to the 55th day. So there are 30 men working. Then on the 56th day, we have 20 additional men. So we have already 50 men working. And then we do not know how long these 50 men finish the work. So if we add, so if we form the equation 30 times 80 equal to 20 times 30 plus 30 times 25 plus 50 times x. So we can now solve for x. That is equal to 21. So if we add, then we have 30 plus 25 plus 21, and that is equal to 76 days. Next problem, we have 3 men can assemble 3 kiddie chairs in 5 days. How many kiddie chairs can 5 men assemble in 6 days? Okay, so for this problem, so we have 3 men in 5 days. So we have 3 times 5 man hours or man days. Then we have 3 chairs. And that is equal to 5 men working for 6 days. Then how many chairs can they assemble? So by proportion or equating the man-hour per unit work in the first equation equal to the man-hour per unit work in the second equation, we can solve for x equal to 6.